All right, we're going to be looking at two theorems, and these two theorems deal with the two special right triangles. So first off, theorem 8-6. Which tells us about the 45-45-90 triangle. First off, if you're looking at a triangle with a 90-degree angle that has two 45-degree angles, what do you know about this triangle? If you have two 45-degree angles, what do you know about this triangle? It's right, okay. What else? It has two 45-degree angles, very good. What else? The sides are equal. Why are the sides equal? Because the angles are. So these two sides have to be equal. Now, if I call those two side lengths A, let's use Pythagorean theorem to find C. I'm actually doing the proof of the theorem before I write it. Okay? So if I use the Pythagorean theorem, the sum of the squares of the legs, a squared plus a squared, will equal the square of the hypotenuse, c squared. Because these are like terms, I can add the coefficients in front. This is 1a squared plus 1a squared. That gives me 2a squared equals c squared. And then when I do the square root of both sides, I will have c equals the square root of 2 times the square root of a squared. What is the square root of a squared? So, since that's a whole number, I'll write it in front of the square root of 2. A times the square root of 2 is what c is equal to. So, c here will always equal the length of the leg times the square root of 2. Which means, if I have a right triangle with 45-degree angles, and I know that this side length is 7, what will this side length be? 7. So the legs are always equal. And what will the hypotenuse be? 7 times the square root of 2. You can prove it to yourself if you want to. 7 squared plus 7 squared is 49 plus 49. When you add them, you get 2 times 49, right? And then you take a square root. The square root of this piece will be the 7, and you'll be left with the square root of 2. So you get 7 root 2. So our theorem, in a 45-45-90 triangle, the legs are congruent. And the hypotenuse is square root of 2 times the length of the leg. Now I'm going to do one more 45-45-90 triangle. I'm going to make it more difficult. Maybe I'll do 2 more, because I have 2 levels of difficulty I'm thinking about right now. What's that? Yes, it is. This is our explanation. Okay, so here's the first level of difficulty I'm thinking about. We know that we have a 45-45-90 triangle, and we know the hypotenuse. We do not know the legs. So we're going to say the hypotenuse is 5. Now, I know that 5 as the hypotenuse is equal to the length of the leg times square root of 2. Right? the hypotenuse is equal to a times the square root of 2, where a is the length of the leg. Call this a and that a. So how do I find a? Since the hypotenuse is equal to a times, I would divide by square root of 2 actually. To get my a alone, I'm going to divide both sides by square root of 2. So I have 5 over the square root of 2 equals a. But I have to rationalize that denominator. I can't leave the square root in the denominator. So I have 5 root 2 over 2 is a. And that's what I give as my answer. Okay, my next level of difficulty. What we're going to know is the hypotenuse is 5 root 3 over 3. Next level of difficulty, 45, 90. Hypotenuse is 5 root 3 over 3. Now, still, that's the hypotenuse. So that is in fact equal to, as the hypotenuse, is equal to the square root of 2 times a. And my leg is a. So, what do I have to do? Divide by square root of 2, right? But what does that look like when you're working with fractions? Times a reciprocal. So dividing by the square root of 2 is the same as multiplying by 1 over square root of 2. And that's what we're going to do. We're going to multiply by 1 over square root of 2. Which means this is going to be 5 root 3 over 3 root 2. Because 3 times root 2 and 5 root 3 times 1. I have to rationalize the denominator. How do I do that? Multiply by root 2 on top and bottom. So I'm going to get 5 root 6 over 3 times root 4. So over 6, because root 4 is 2. Let's move that up. Okay. Let's move to our next theorem, which is our 30, 60, 90 triangle. Theorem 8-7. All right, to do this, let's first look at a 30, 60, 90 triangle and talk about it a little bit. My 30, 60, 90 triangle, because the angles are different sizes, we'll have sides that are different sizes. Remember our theorem that said that the angle opposite the, the side opposite the largest angle must be your longest side. So since this is 90 right here, the hypotenuse is the longest side. What's the next length side? The one that's opposite 60. And then the one opposite 30 is going to be your short leg. We're going to name the short leg A. Now, if I clone this triangle here and then flip it so that it's back to back with that triangle, what type of triangle will I have? Yes. So I do that, and because I can't draw a beautiful right triangle, it doesn't look beautiful, but what we should have there is an equilateral and equiangular triangle. Which means, since this side length is A, then the whole side length, or rather all of the sides, are going to be 2A, right? So this is 2A, as is this, and this is A plus A, which is 2A. Now I did all of that just so I could know that here in this right triangle, the hypotenuse is 2 times the short leg. Now I can use Pythagorean theorem to find the long leg. I know the hypotenuse is going to be double the short leg. Using Pythagorean theorem, I know that a squared plus b squared equals 2a squared. And I write that as 2a in parentheses squared, which I know becomes 4a squared. And since that's a like term, I can subtract a squared from both sides, giving me b squared equals 4 minus 1, so that's 3a squared. Now I can take a square root of both sides, and when I do that I have b equals square root of 3 times square root of a squared. Square root of a squared simplifies, and since it's a whole number, I put it in front of the radical. b equals a times the square root of 3. And that's what the long leg is. So I'm going to erase the b here. I found that to be a times the square root of 3. So in a 30, 60, 90 triangle, the hypotenuse is always 2 times the short leg, and the long leg is always square root of 3 times the short leg. So now we're going to work with some examples of this. If we have, now why is that not moving? There we go. Okay. So if we have a 30, 60, 90 triangle, we're going to have a long leg, we're going to have a short leg. The orientation is not important, so I could have my 30, 60, 90 triangle, which looks like this, or however I choose. But always, the angle that's going to be opposite your short leg is your 30-degree angle. Okay? So now, working with this, if I know the short leg, which is the very easiest triangle to solve, we're going to say our short leg is square root of 5. If that's square root of 5, what will the hypotenuse be? Because you take 2 times the short leg, it's going to be 2 times the square root of 5. What will the long leg be? Now you think, to find the long leg, you take the short leg times square root of 3. So you're going to take square root of 5 times square root of 3. What do you get from that? So square root of 15. Making it slightly harder, Nick, you need to be paying attention. These are not easy. Okay. So making it slightly harder, on this 30, 60, 90 triangle, we're going to know the hypotenuse. We're going to say the hypotenuse is 7 root 2. Now what I know about the hypotenuse is that it's equal to 2 times the short leg. So if the short leg is a, this is 2a. So I set up an equation, 7 root 2 equals 2a. And I'm going to solve for a, which means I have to divide by 2 on both sides. So my short leg is going to be 7 root 2 over 2. Now the question would be, what's the long leg? Well, I know to find the long leg, and I won't erase that, to find the long leg here, I have to take the short leg times square root of 3. This is the short leg, so this is 7 root 2 over 2 times the square root of 3. So I have to think of that as over 1, and when I multiply fractions, I multiply the tops and then I multiply the bottom. So I get 7 root 6 over 2. So the long leg here, 7 root 6 over 2. One more example, maybe two, depending on if I think of another level of difficulty. So here I have 30, 60, 90 triangle, and I'll change its order again. We're going to make it face this direction. Opposite the short leg is your 30-degree angle. We're going to know the long leg now. It's the hardest one. So I'll make it easier the first time, and then we'll work with harder the next time. We're going to say the long leg is 7. I'm starting to make it harder already, and I'm going to not do it. So the long leg is 7. I know that if the short leg is a, then the long leg is a root 3. So I know that a root 3 equals 7. I want to find a. So using algebra, divide by root 3. Which means I'm going to have a equals, and I have to rationalize the denominator, 7 root 3 over 3. And that's what a is. And I'm already starting to take some of the shortcuts, so like I didn't say how do we do that, I just did it, right? So if I confuse you, stop me, and I'll go through it. Okay. So a is 7 root 3 over 3. Now the question is, what's the hypotenuse? Well, I know the hypotenuse is 2 times the short leg. So I'm going to go 2 times 7 root 3 over 3. That's 2 over 1, so you just go 2 times the top over 1 times the bottom. So that's going to be 14 root 3 over 3. This is 14 root 3 over 3. Okay, one more level of difficulty. Okay, here we have another triangle. I'll set it up this way this time. It's a 30, 60, 90 triangle. Always opposite your short leg is the 30. We're going to know that long leg is 5 root 2. So I know 5 root 2 is the long leg, and if the short leg is a, and it's a root 3, that equals your long leg. So will equal 5 root 2. So now I have to solve for a. So I'm going to divide by root 3, which is going to give me, when I rationalize that denominator, what? Yes, 5 root 6 over what? So my short leg then is 5 root 6 over 3. Now, the hypotenuse is 2 times the short leg. So I go 2 times 5 root 6 over 3. Thinking of that as 2 over 1, it just multiplies times the top. So I'm going to have 10 root 6 over 3. Okay. Now, your assignment is this type of thing. Page 302, you have a green box, and I think you were telling me that that's a goldenrod color. It's not yellow, it's not orange. So you have a green box and you have a goldenrod box on page 302. Let's stop this.